Hello class, this video is going to be how to conduct a RANOVA in the program Jamovi. So I've already opened my file and I'm in the data view and we have 4 different variables. Our first variable here is just our ID. Our second variable is positive mood. Our second variable is neutral mood. And our fourth variable, I should say, is negative mood scores. Okay. So when we look at the assumptions of a RANOVA, repeated measures ANOVA, we also always have to do chapter 2 and all the good data cleaning and all the things that we've done there, and z-scores and outliers and data entry errors and all that kind of stuff. But there are several different assumptions that need to be met for RANOVA, some that you remember and some that are new. So some of the ones that you remember are sample representative, and in this scenario we're going to assume that the sample is representative based off of the description provided in the homework. The second one is level of measurement, so it has to be interval or better data, so both positive mood, neutral mood, and negative mood, they all have to be at least interval or better, and these are actually ratios, so we're good. The third assumption is sample size, and unlike a between subjects design, in a within subjects design, our magic number is generally just 30, and it's 30 per variable, but not, remember this is within subjects, so when one person fills out positive mood, they're going to get a neutral mood score and they're going to get a negative mood score. So essentially, yes, it's 30 per variable, but they're all doing the same variables. So we only need to have 30 or more participants to get generally good power. I'll let you be the judge. Maybe look at this number right here on whether we meet that assumption or not for the homework. The next one is normal distribution. And remember, that's just kind of how we do it or how we typically do normal distribution. We would go into explore, descriptives. We're going to move our 3 variables here. I just hit shift and move them over, click on stat, and we want the skewness. And we would divide our skewness by its error, so 0.092 by 0.45. And I'll let you be the judge of that. If you need to do any transformations, do them. When we go back to data view, I'll move this up here. Another one is homogeneity of variance. You only have to do that if you actually have, if it's a mixed RANOVA, meaning there's some between subjects variables. And you do not in this scenario have any between. And then normality of distribution, right? And we're going to check that. The new assumptions we have are assumptions of sphericity, compound symmetry, and range of scores. And I'm going to show you how to do that. But let's first talk about range of scores. Essentially, for range of scores, each of your measures, or of your within subjects measures, and that's positive mood, neutral mood, negative mood, they all have to be measured on the same range of scores. They don't have to be the same range of scores. But in this case, it ranges between 0 and 20. And so negative mood has to be on a scale that ranges between 0 and 20. So does neutral, and so does positive. So we meet that. If you didn't, you would have to do some data transformation to make them the same scale. So how do we test for the assumption of sphericity? Well, essentially what we're going to do is we're going to run the RANOVA. So how do we do that? Click on Analyze or Analysis. Click on this ANOVA tab here. And then click on this right here, which is the repeated measures ANOVA. So much like in SPSS, we have to define our terms. And the more specific you are, the easier it is to read the output. So first thing we're going to do is we're going to define the factor. And we're going to call this mood. And then level 1, we're actually going to rename to positive mood. Level 2, we're going to rename to neutral. If I can, oh my gosh, thank you. Neutral mood. And then level 3, negative mood. And notice how it kept on populating things down here. So we want to make sure that we drag our correct variables to the cells that we want. Neutral mood to this cell. So we move that, hit the arrow, We hit on the negative mood and move that. Notice I didn't spell negative correctly, so I'm going to go back and change that. Put the O in. All right. We do not have any subject between subject factors right here. That's if you had a mixed RANOVA. And we are not looking at covariates. You might want to look at age or something like that if you think it is changing the way the DBs perform. Always want to collect on partial eta squared. That gives us our effect size. So the great thing about Jamovi is it just automatically populates everything, which is great. Here's your descriptive statistics up here, which is what you'll need. But what right now, we still have not assessed the assumption of sphericity. We just ran a RANOVA. So we want to click on assumption checks, and we want to click on sphericity tests. We want to unclick the none, and we want to click on the greenhouse Geyser and the Hohenfeld. So those are corrections, okay? So how do we read this? Well, what we're going to do here is for our assumption of sphericity, we're going to read this box. And there's our Mauchly W's statistics, 6.622. And you're going to report this in your assumptions paragraph in your SPSS write-up. It is 0.003. So much like a homogeneity test, like Levine's test, we don't want this to be significant. When it is significant like this, that means we are violating the assumption of sphericity, meaning they are not similar normality across the pairs. So which one do? We look at, as we suggested in the lesson, you take the greenhouse Geyser or the Hohenfeld, which one is greater or close to 1? And that would be the Hohenfeld. So that's the correction. And so when we go to report our F value, we actually read from that line. So here's our ANOVA table. There's the Hohenfeld. There's our sum of squares. There's our degrees of freedom. There's our mean square. There's our F value. And it's less than 0.001. And we have a large effect, meaning 75% of the variance of these three different mood scores is explained. Okay. So now we need to know where those differences lie. Thankfully, the cool thing is that Jamovi allows us to run post hoc test. And so when I click on the post hoc test here, I have to include mood over here into this box. So I just clicked on it and moved it through the arrow. And the beautiful thing is it runs it, and we now know where the differences lie. So if we look at this, there's a difference between positive and neutral as the p-value is 0.001, and there's a difference between positive and negative as the p-value is 0.001. But there is no difference between neutral and negative. See, the p-value is 0.90. And you can do Tukey or Chaffee or Bonferroni, but we have equal size, so let's just use Tukey. Now we need to create a graph. So we click on estimated marginal means, and we're going to put mood into our term. And the cool thing is it shows it right there. And you can also do a means table, and the means table tells you your mean and standard error. And you can tell by the means table that positive mood is 17.4, our neutral mood is 10.7, and our negative mood. Remember, we go back up to the post hoc analysis and we're able to tell this. So we know that there's a significant difference between this score and this score, and this score and this score. But there is not a difference between here and here. And so that's kind of the general, that is all the information that you have that you need for your write-up. And let me kind of rehash that again. So we're going to scroll all the way up to the top. So here's your descriptive stats. It tells you whether you have normality or not, and then you'll need to fix it if you need to fix it based off of the transformations of square root, log, reflect, and all that kind of, and inverse. Here's your ANOVA analysis. The first thing you check is Mauchly's W and the p-value. We know that we are violating this assumption, and we know that the Hohenfeld is closest to 1, so we read that line in our ANOVA table instead of the greenhouse line. And so if we come up here, There's our Hohenfeld. There's our sum of squares, degrees of freedom, mean square, our F value, our P is less than 0.001, and our FX size. The next thing you need to look at is post-hoc tests, and you need to report the mean difference, standard deviation T's, and degrees of freedom, and p-values. Again, we know that there's a significant difference between positive and neutral and positive and negative, but there is not a significant difference between neutral and negative. As always, if you have questions, please email or call me, and I hope this video helps you out. Have a great day.